So this is going to be a short tutorial of how to set up a project in SWM. So open up your program that you've downloaded from the link using my my email and my license number that I provided to you. So when it opens up, you should see this. If you click on the Manage button on the left-hand side, you'll see any saved projects you've been working on previously. But I'm going to show you how to set up a new project. So you click on New on the left-hand side, and then click the SWM5 project. It's going to prompt us to save it. So I am going to call this Urban Hydrology Bucket because I'm going to be setting up our model for just the white bucket. Oh, still loading. Once it's fully loaded, this middle section will be blank. That's fine. And you should see all of the layer options on the left-hand side here. So to first set up our map, we need to go to the lower left-hand corner, click Bing Satellite Map to set our view preferences there. Now we need to zoom in on our specific location. So we're right in here between Lake Erie and Lake Ontario. So zoom, zoom, zoom. St. Catharines. And our site is right in this area here. So we want to zoom and we'll see the church roof soon. This is the Meridian Center. So the church is right here, northeast of that. So we'll just zoom in like this. Okay. Here's the church that we did our experiments on. Remember, we took measurements on this side of the building. And this is that other building where we installed the white bucket with that black little house on the east trough on that corner. And we took measurements on this grass here. So I'm going to be setting up the model for this, the white bucket, which is this building here. So first what we need to do is we need to tell the model what our subcatchment is. We need to create a subcatchment to tell the model what area we're draining or what area we want to look at. So click subcatchments on the left-hand side there, so it's highlighted. Then you click add, and then we're just going to click on each corner of the building. Create our mini watershed because we're looking at all the water draining from this roof. So this is going to be acting as our subcatchment. Then we're going to click commit changes. Yes, auto length is fine. Second, we're going to create an outlet for our subcatchment. So to do this, we click outfall, not outlet, click the add button, and then we create an outlet. I'm going to put it just on the sidewalk there. No, I click. So it's telling us that our outlet is somewhere in this area, and that's where the east trough discharges to, right? So that's fine. The next thing we're going to do is create a conduit. So click on conduit. Tell the model that we want to connect these two things, that they're connected, that this subcatchment is connected to this outlet. So click conduit, we'll click add again. Then you can click anywhere in the subcatchment, press control first, hold control button down, then click, then release control and click your outlet, and we'll see a little conduit form. Now we've just told the model that this subcatchment is connected to the outlet. It doesn't matter where you click because we're just linking the two. So then I am going to click my select button again so I don't accidentally add more points. And so we'll come back to this in a minute, but first we're going to upload rainfall data to tell the model which rain data to use to estimate runoff. So click graph here, graph tab at the top. Then we're going to open our data. So this is the data I have supplied to you. It's in that big spreadsheet with the pressure transducer data. So that is this spreadsheet here. It just takes a second to load. So there's our spreadsheet. Your spreadsheet will probably, because you're uploading it for the first time, it'll look like this where all columns say ignore. So we want to change that because we want the model to use specific columns. So we want to change this one to date time. So it identifies it as a date and a time. And then this second column here is rainfall. So we want to click value. Then on the second drop down, we click rainfall. Then we enter in our units. And then I'm going to call this rain observed. Another thing I've done here is I've told it to skip the first two rows because the first two rows in our Excel file are just words. So skip the first two rows. So we're starting at the data. And then you want to make sure that this date format in the right corner here matches the date format in the spreadsheet. If it doesn't, you just click on the three dots and you can adjust it. And then we click OK. And that's fine. You can just click proceed. It'll still work. And I can say, yes, save current configuration set. So we'll be prompted to save it here in a minute. And we're saving it as a binary time series file, and that's just the type of file that the model reads. So when we save it, we won't have to re-upload an Excel spreadsheet again. It just saves our settings and our data within the model. So that makes it easier for us. Okay, voila, and here is our rain data. The next thing we need to do, come down to these options at the bottom so you can collapse them or open them using this arrow in the bottom right-hand corner. We need to manipulate this data a little bit. So right now it's in a depth, but we don't get any summary information while it's as a depth. So we're going to manipulate it to be an intensity. So click on edit, go to convert, and then the third option, convert rainfall depths to intensity, and make sure the correct data is selected there. And you click execute. You'll notice that the data on the side here, this little file is turned red. That just means it hasn't been saved since there was changes. So once I save it, that turns yellow again. Okay, so our data is uploaded into the model. We now need to assign it to a rain gauge in the model. So we click menu, add to time series editor. Here's our data. We go to options, create rain gauge. We want it in intensity format. Okay. Our rain gauge has been created. Wonderful. Then we can click OK. The next thing we're going to do is we need to make sure the date of our simulation and the data line up. So go to simulation options here on the left and go to date. And you'll see that start analysis on this is today's date. So we want to change that. If we ran the model right now, we'd get no results because it's starting after our data. So we just need to tell the model when to start. So we start September 20th at 17, so 5 o'clock, and it ended on November 5th at 10 in the morning. Okay. Now we can go back to our map and we're almost ready to run the model. What you need to do is click on the subcatchment. So it's highlighted in blue or whatever color your computer makes it. And we're going to change some parameters of the subcatchment so it's more specific to our scenario. So first we're going to find this rain gauge attribute and we need to click, this is the rain gauge we just created. So we're just assigning that rain gauge to the subcatchment. The outlet we need to select, that's OF1, that's the red triangle, and you'll see when you do that, it adds those red dashed lines. The slope is 1%, so that's the slope of the roof. This is percent impervious area. So if you go look at the bottom here, it gives a little description of the parameter that you've selected. So percent of impervious area, that is 100% because we're on a roof. This is the Manning's number for impervious area. So remember, Manning's number is a measure of roughness that water flows over. So it's pretty low. A low Manning's number means it's a smooth surface. So we're using 0.015. Manning's number of pervious doesn't matter. We don't have any pervious area. Depression storage for impervious is 2 millimeters. So that's basically just the lip of the roof. So some water is stored on the roof before it is transmitted to the eaves trough. The last thing we're going to change is this zero impervious percent, and that should be 0%. And now this is ready to run. So I'm going to save it just so it saves all of our current settings. And I'm going to click run. And good, we have a check mark here. So that means it was successful. If we go to the graph tab, we'll be able to look at this data. So you'll notice on the left here, we now have a SWM output file. So if you click on subcatchment, you expand that, expand runoff, and check S1, that's our subcatchment 1, we now get a hydrograph. This is our runoff data for that eaves trough. On the left-hand side, you'll notice there's a little summary of results. So we had 55 millimeters of precipitation, 53 impervious runoff. So our runoff coefficient or rainfall runoff ratio is 0.978. So that's the runoff divided by total precipitation. So that makes sense. Most of the water that's falls as rain runs off. You might get slightly different numbers, but as long as you're in the 50s for runoff, you've done it correctly. Another thing you can do is zoom in on certain events. So in your assignment, I ask you to examine the November 29th event. So we can zoom in on that here. And then you'll be able to compare those two hydrographs. So for example, you could look at the difference between lag time between the modeled data and our actual data. So that would be the time of peak rainfall to the time of peak runoff. So I'm not sure what that looks like. I honestly haven't looked at the real data, so I'm interested to see what your report says. So you could talk about that. You could talk about how our total runoff compares to our actual data and maybe why you think there might be differences based on model assumptions or how we've set things up. And then to export the data, we go back to File over here, click Save and Send, export time series to Excel. So then it'll prompt you to save the file. Just got to think about it. And then you want to change the file type to Excel. And I'm going to save it as swim model data, maybe bucket. Save. And you'll see there should be a bar at the bottom that tells you that it's saved. So maybe it did that already. Oh, it's thinking about it. Oh, there it goes. The green at the bottom, saving table 1 to Excel. There's a lot of data points, so I'm not surprised that it's taken a little bit. But then you'll be able to graph that data from Excel. Just give it another second here. You can do it. I guess while we're waiting, we'll just talk about, oh, error. That's fine. you can just click close. So you'll need to create a new file for the church. I found if you create the subcatchments on the same project, sometimes SWM gets confused. So I would go to File, New, and create a whole new project. But you're going to do the same thing for the roof. This area here is what we're using. And the only other thing you're going to change is the slope. So the slope of the church roof is obviously much greater than a flat building. So we made an educated guess that's between 30 and 40% slope. So that's just going to mean water's delivered to the eaves trough more quickly. So that might affect lag time. Probably won't affect total volume, but we might see some changes in lag time. So set it up for the church and do the exact same thing. Let me know if you have any questions. I'm happy to meet to go over your results or help you with the model.